Everyone, I start my presentation. Uh, this paper belongs to the area of reasoning large language model, and the title of paper is Mutual Reasoning Makes Smaller LLMs Stronger Problem Solvers. And these are the authors, and Microsoft Research Area and Harvard University is the affiliation. And this paper is published in ISLR 2025. So, the main problem author addresses in this paper is large language models still struggle with complex multi-step reasoning, especially on the mathematics and the logical tasks. So, as this problem is more becomes more severe in small language models, which often explore ineffective reasoning paths and cannot reliably evaluate or verify their own reasoning. And all the existing solutions, they require either the fine tuning or the training from the teacher model. So, why it is important? Improving the small language model reasoning without fine tuning or stronger teacher model, it reduces the training cost and dependence on the proprietary LLMs. And it enables small language models to perform more accurate reasoning at inference time, making them more practical for real world and resource constrained applications. So the core idea of this paper is they uses the Carlo tree search augmented with small language model to generate many reasoning trajectories. And they also introduces five human-like reasoning actions. And also they use another SLM, another small language model as a discriminator or a verifier uh, w- um, to do a mutual consistency. So the main contribution of the main contribution of this paper is they introduce the rich action space based on the MCTS search space, and they have the two SLMs. They use two SLMs, two models, small models. First act as a generator model, and the second SLM act as the discriminator model. And the state of the art inference time reasoning across, they use five different small language models. They test all the experiments on these five different models with five data sets. And this is the experimental setup. They focus on the mathematical and common sense reasoning, and they used these data sets, these five data sets, GSM 8K, GSM Hard, Math 500, and SWMP and Strategy QA. And the baseline, these are the existing word present, which already uses this MCTS search. This is chain of thought, COT, self consistency, and tree of thoughts, and RAP. And they evaluate the matrix accuracy. And their experimental results shows that the huge improvement over the baseline experiments. So they take Llama 7 billion model, which has the accuracy of 12.5% before their R-star technique, and after they applied their technique, there is a huge improvement, which is 63.9% on this grade school math data set. So the background and motivation, they achieved the remarkable LLMs achieved although remarkable success in all the tasks, but they still struggle with the multi-step reasoning. So, and they also says that even when the LLMs are still struggle in the reasoning tasks, then the small language models are becomes automatically more severe. And the solution to these reasoning tasks is the fine tuning. One of the solution is fine tuning, and the other solution is using the stronger teacher model uh, do the to correct the reasoning. But these all these two strategies, they require the training, additional training, or training the another stronger model. So their work solely based on the all the reasoning in the during the inference time, and they didn't use any fine tuning and any another model, trained model. So the existing word limitations is basically these were chain of thoughts, self consistency, wrap, and self rewarding and fine tuning methods, as I told earlier. These uses the MCT, Monte Carlo search, the traditional Monte Carlo search, and they which is also not very effective in the this reasoning capability, reasoning task. So they introduced the new method based on the Monte Carlo tree search. They basically improve this Monte Carlo tree search over the existing work. For example, the wrap in the previous existing work, they uses the action which I will use later. So okay, I will tell the all five actions they use in their R star strategies. So they used these five actions, as you can see in the figure, A1, A2, A3 to A5. So A1 actions says that they if we have a prompt which have we have to give to the SLM, but first we break down or decompose that prompt into these five actions, and that prompt goes to these five actions and made this tree search. So first, A1, it means that the propose a one-step thought only, not a whole thought process, just like we done in the chain of thoughts. And the second, A2, denotes that the complete remaining thoughts after the one-step thought. A3 shows that it proposes sub questions. Like if we have a question, then it breaks down the question into sub questions. And the A4, what A4 does is it re-answer the sub question. So these are connected, A3 and 4, and the A5 is whatever the question is, the root question, it rephrases that question and these all five action is for that small language model, and make them perfectly perfectly perform the reasoning task. So the overview is simple. The input question is initialized first as a root node, and this um, root node of MC search tree, and then this MCTC search reasoning action. This they perform their action like as you can see, this is the root node, this is the question, and these are their nodes or child nodes. So whenever uh, these nodes are there, then MCTC first decide or select which action I have to choose on these nodes, and then after the action is selected, then after that selection, the prompt is sent to the SLM, and then SLM generate the next thought. Then the next steps are generated, and then after this process is repeated, then again MCTC search select based on the next step. Based on the next step, MCTC selects which action I have to use, I have to choose. So then after that action, it gives the prompt to the SLM. So this SLM is augmented with the MCTC search and generate all these prompts and all these steps. So this diagram shows the first two their whole methodologies is basically the three they uses three main ingredients in their project. First is the MCTC search, and then second is the small language model 1 SLM1 as a generator, and the small language model 2 SLM2 as a discriminator. So these search tree and all the prompts and actions, these are handled by this MCTS and SLM1 only. And then the process of the this is the process of the discriminator, how discriminator is used, which is basically discriminator. The role of discriminator is it only verify the whole whole the steps, reasoning steps performed by both of previous MCTC and SLM. So this is the all the reasoning steps, all the answer performed by the SLM1. And for SLM2, after their all the search and all the answers, SLM2 what does is they give the SLM2 half of the or the partial thought generated by the SLM1, not the full thought. And they ask SLM2 to generate the full task, and then they verify that they have the consistent answers or not. So that's how they use the MCT search with richer five action space to improve their reasoning, and then also they does not only rely on that MCT search, they also use the second discriminator SLM2 to verify their reasoning steps. So this whole combined and then improve the overall performance. So this is their whole complete pipeline. First the input question, and then initialize the MCDS tree, and then it selects the action from 1 to 5, and then the SLM1 generates the next reasoning step. Then that's how the tree is expanded. And then after the terminal node, which is the end node, after the terminal node they also introduce the reward function to improve the MCTC search, and they compute the reward, and this process repeated until all the selected rollouts. Rollouts mean this whole process repeated how many times, so how many trajectories we have, how many search we have. So and also they in parallel this the SLM2 also verify all these trajectories by taking the partial steps and completing that partial steps, and then matching the steps of the previous and their own. So that's how they give the final answer. So this whole pipeline, this improve the reasoning capabilities of small language models, significantly improve their capabilities only by prompting and tree search. And the key components of their whole R star project is they use this MCTS, which explored the multiple reasoning part, and they use the five action space, A1 to 5, and which provide the more diversity. And they used the reward function, which actually guided that whole MCT search, and also the mutual consistency, which I told the used by the second SLM2, which because it also take the partial reasoning steps, and then complete the partial steps, and then they both validate each other's steps. So in this paper they call this process as a mutual consistency. And also there's no loss function related, because they perform they all done all this work in inference time only. And they uses the 32 MCTS rollouts. Means they perform they're talking about their tree search 32 MCT rollouts. And also, this is the experiment. They performed this experiment on these data sets, and they uses 5 different models to validate their improved results on 5 different models. And they use 32 rollouts, and also they use depth of they're talking about depth of the tree. They uses 5 mostly, and but for the math they uses the higher depth for 8 depth. And they evaluated the accuracy metrics, and this is their result. And they achieved the huge improvement over the previous existing methods. And R star they perform on Llama 2 7 billion model, Mistral 7 billion model, and the Llama 3 8 billion instruct model. So in all the three models, they achieve as you can see, R star, this orange or red line. They achieve the significant improvement over the existing methods. And they also done the ablation studies. Here they tested that um, as they use the five actions, rich space actions in their existing R star method, but they only tried the individual actions, and see the results, see the accuracy, as they based on the A3 action, which is also used in the RAP existing method. They achieved the 70% accuracy. And when they combine A3 action with A5 action, they achieve the 72. And similarly, after achieving all the actions, after using all the action, they achieve the best accuracy among all. So using the 5 actions is better than using the uh, only 2 or 3 actions. And also, next, their strength of this paper is, as they didn't use any fine tuning. Don't require any fine tuning, and they don't require any stronger teacher model like GPT-4 or something to improve their reasoning capability. So they use only the 2 small models, and they show that they also can improve just during the inference time. And limitations are in this paper is, as they use the multiple rollouts during the tree search. So these rollouts cost the increase the computational and inference latency. So the future work can be by reducing that inference cost, which is produced by these MCTS rollouts. And also, this work is extended to additional domains such as the code and generation, scientific reasoning, and multimodal tasks. The key takeaways is, the reasoning quality can be improved without changing model weights. And also the search strategy is very important, as we have a very importance in the model size. So the last is idea to relevant the Segyol AI project is that this paper demonstrates that the reasoning quality can be improved during inference without retraining. And this idea could be integrated into this Segyol AI project by adding a reasoning layer within the private AI control panel, where private models explore multiple reasoning paths and verify them before producing the final response, and improve both the reliability, explainability, and also trustworthiness. And also, a search-based reasoning combined with independent verification would allow lightweight private models to achieve higher reasoning accuracy while reducing computation and training costs. So that is it from today. If you have any questions, then you can ask. Yes.
Maybe more. Firstly, I
Mhm.
don't understand what is the meaning the rollout.
What?
Rollout. Under
Rollouts.
rollout.
Rollouts. Okay. These rollouts, like when we initialize a question, that is a root question, then MCT uses the action. one of the 5 actions, and then that action is give use as a prompt to the SLM, to the model, and then this process happened again and again until the terminal node is happened. So this is complete process is one rollout. Yeah. So they use 32 rollouts.
So 32 times
Yeah,
the data tree.
Yeah.
And then go to the output.
Hmm.
It is not the training or any kinds of fine tuning or
Yeah.
other.
No, not any kind of fine tuning and training.
But
They
I
are.
have a question. So how to define the discriminator?
Discriminator is a second model. They use two models.
It is just using the code.
Yeah, second model is used the which I told earlier. Second model is used. Okay, I tell you like this. Second model only uses the partial reasoning steps performed by the first model along with the MCTCS. So they only uses just take the partial steps as a prompt, and they ask them to ask it to complete the reasoning. So it completed the reasoning, and then they validate the result, the discriminator result and the generator result. They match the result, and if they both give the same result, so it means they have mutual consistency, so they consider that result as a final result.
Thank you.
Yeah.
Let's go to the flowchart.
Flowchart.
Yeah, here. So the input actually decomposed with the action space, 5 action space. So how they are generated? I mean, how the action is generated? Is it deterministic action or is it probabilistic action? So based on
The deterministic actions, these 5 which I defined here, these 5 actions. These are deterministic, and they among these 5 actions, the responsibility of MCTCS, they select it MCTCS select one of the action among these 5 action for that specific root question, or for that specific step, and then after selecting this one of these actions, then the uh, like question, and then action A, let's suppose action A is selected by MCTC, then that action based on the question gives to the as a prompt to the SLM, to the model.
Second SLM.
No, first.
Okay.
This all the MCTC search, these 5 action, these all happen between the SLM1 and MCTC.
Okay. So there's out of 5 action space, it took only one action, right?
Yeah, one time one action.
One time,
Yeah.
one action. So once the first action done, they send it to the SLM to generate the response.
Next reasoning step. Yeah.
Next reasoning step. Until that, there is no other action. So once the SLM finish that generation,
Yes.
then again it starts from the same action space. It take another action.
Yeah, based on the next reasoning step generated by the SLM1, then MCTCS again decides which action to select based on that.
Out of these 5, or they will again
Out of these 5.
Other 5 action space and from
No, out of these only. Out of these. Whether we need to they MCTS decide whether we need to produce a further next step, or whether it need to produce the all the remaining thoughts, or whether it need to decompose the problem to sub questions, or whether it needs rephrasing to better understand the by SLM. So it decides by the SLM, and after the all the this one trajectory, then at the terminal node, then from all of the trajectories, they do the they give the rewarding, use the rewarding function. So they give the they do majority voting, and then they give the reward, each of the trajectory, and then that reward is back propagate to every reasoning step. And that's how MCTC is guided by this reward function also. And then
they are selecting the best path.
Best path, yeah.
Okay. So this is one trajectory. So you are saying 32 times
32 rollouts means 32 times MCTC decides different actions. They use different, yeah. Tree, like a tree.
Whole action space based on the whole action space. 32 times they are reasoning.
Yeah.
But in one action, they are taking one action, they do some reasoning, wait for the next action, then go for the next action. In this way, they are finally come in the, based on the reward function, they are finally selecting what would be the best path. And how they connect all those reasoning. Because every step, one step reasoning, then there is another.
Yeah, they are not completely separated steps. Like when you have a root node, then it have a two child node, and then from the two child node, then again child node, and then all the trajectories have some shared space also, shared trajectory or shared path also. So that's how this uses this whole the trajectory thing, like uses they use the shared path also, not very separate trajectories.
Can I just keep, say for example, this diagram. The action space is the white block is the action space, right?
White block.
I mean, the first one, there are two color of background white and background green, right?
Yeah.
Okay. So if you say that the first one is the action space, then the other one is the reasoning space, right?
Yeah. First one is the root question.
Root question.
Yeah, root question,
Based
and
on
other
the
one.
question,
Yeah.
they have some action space.
Action space. Yeah.
So they select one action.
They select, like based on this. They select this blue line, as you see, action one, this blue arrow. This step is based on the action one after the root.
Okay.
This step is red A3. This step or this child node is generated based on the action 3.
Yes, my question is, see, when they select the root action, then they come in the left trajectory. They come in the solution. Then how they go back again and connect with the second action space? You got my point?
Sorry.
Okay. So the root node, they select one action space, the left trajectory, they come and they come as a tree format, right? Then they found some solution, the reasoning. That reasoning is based on that reasoning, they will select the second action.
Based on you are saying that based on this first trajectory,
yes,
they are doing this second trajectory, but they are in parallel.
If it is parallel, there is no relation between the action space. They took all action space, they do it.
No, they took all action space, and then after the tree is generated, a trajectory is generated, they are doing the reward function.
Yes.
Yeah.
In that case, according to my understanding, they are taking whole action space. They are parallelly doing the task. They extend their root and branches, and finally, when they reach the terminal stage, they start giving the rewards. And finally, based on the reward, they are selecting which action trajectory,
which is the best. Yeah. Right? Which is the best. Yeah.
Oh.
Okay, if you don't have any questions further, then I can stop my presentation. Thank you for your listening.